Hi, gang. I am off having doctor's appointments, and I'll be back tomorrow. This is nothing serious. Today is Tuesday, March 21st, and you're going to cover 11-2 permutations. It's pretty easy as long as you've got your handy-dandy graphing calculator or a calculator with an exclamation point button. Anyway, have a great day. I'll see you Thursday. Okay, a permutation is an ordered arrangement of items that occurs when no item is used more than once and the order of the arrangement makes a difference. So this is actually kind of important when you're doing homework that isn't today's homework. Factorial notation, we need to know how to do this in order to know how to do our problems. Factorial notation is this little exclamation point, and when you have something in factorial notation, you just times from that number to that number minus 1, number minus 2, to 3 times 2 times 1. For example, 5 factorial is 5 times 4 times 3 times 2 times 1. Okay, by definition, 0 factorial is 1. I don't think you're going to run into it, but 0 factorial is 1. Now, this is another example of how life is so much easier in math class now. I'm going to zoom in a little bit so you can see the little tiny writing there. Okay, move you over, zoom in a little more. Do you see it? It says the factorial button can be found on your graphing calculator. If you select the math button, then arrow over to PRB, you will see 4:1. Now let's go back. Well, we'll stay right here. If I can get us back in the screen. Okay. Writing's a little small. We have 8 factorial over 5 factorial. So, here's our calculator. Sorry for such a rough video. I'm going to scroll us out a little bit. So the way we're going to do this is we're going to say 8. Then we're hitting the math button. Scroll over to PRB. And do you see number 2? Nope, I went too far. PRB. There we go. Number 4. Went too far again. 4 has that little exclamation point. Hit enter. There we go. 8 factorial is 40320 over 5 factorial. We do the 5. And once again, we go up to math. Scroll over. And down to number 4. Ugh. And enter, and we get 120. Then what we're going to do, we're going to move my paper again. Whee! Feel like we're on a boat. Oh! Okay, Mrs. Lons, quit it. Okay, so then we can either go 40320 divided by 120 and get 336. But you should know you could have done it all in one step. So 8 math factorial divided by 5 math factorial. Okay? So let's look at the next one. It's 7 factorial over 7 minus 2 factorial. Get my calculator back in the picture here. 7 math factorial divided by parentheses 7 minus 2 close parentheses factorial. And we get 42. So it should be pretty simple, but let's keep going with our notes here without trying to look like we're on a boat. Okay. So here's an example of a question that there might be one like this on the homework. You need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference? You have 7 different books you can put in the first shelf position. But then the second shelf position, because you've already put a book here, you have 6 books to put there, which only leaves you with 5 books to put there, and 4 books to put there, and 3 there, and 2 there, and 1 there. So, fundamental accounting principle says we would multiply those all together. So 7 factorial would be the answer. 7 math probability and known 2 factorial. You have 5,040 different ways to put those books. Okay. Now we have permutations of n things, won't say them again, taken r at a time. The number of possible permutations of n things taken r at a time is this npr, which is n factorial over n minus r factorial, which looks pretty similar to this one way up here. So let's do one of these examples. Suppose that you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. So 3 different positions. In how many ways can these offices be filled? Your group is choosing 3 officers from a group of 19 of your friends and yourself, so 20 people. The order in which the officers are chosen matters because the CEO, the operating manager, and the treasurer each have different responsibilities. Thus, we are looking for the number of permutations of 20 things taken 3 at a time. So you would do 20 over factorial over 20 minus 3 factorial. What this means is you can do, there's 2 different ways to do this. It's going to be, you can either go 20, then go to math, scroll over to probability, and then scroll down to number 2, NPR, and our R is going to be 3, so that goes at the end. 20 is your N, 3 is your R. And the answer is 6840. You could also just go ahead and put in the formula. That's totally okay too. Minus 3, math, probability. And you get the same thing. So if you want to use the formula, you can. Or you can just plug in the formula. Either way, you'll get the same answer. If you try and do it individually, I believe 20 factorial is way bigger of a number than will fit on the calculator. All right. Now we move to the back. Permutations of duplicate items. So the number of permutations of the letters in the word set is 3 factorial, which is 6. The 6 permutations are right here. And the question is, are there also 6 permutations of the letters in the name Anna? The answer is no. Unlike Set with 3 distinct letters, Anna contains 3 letters, of which the 2 A's are duplicates. If we arrange the letters just as we did with Set, we obtain this. And we've got some bold letters in there to distinguish the 2 A's. So without using the bold letters to distinguish the 2 A's, there are only 3 distinct permutations right here. There is a formula for finding the number of distinct permutations when duplicate items exist, and it's right here. So you just take your number of letters and then divide by all the duplicates. So let's do an example of that. So in how many distinct ways can the letters of the word Mississippi be arranged? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So N is 11. Where 4 I's are identical, 4 S's are identical, and 2 P's are identical. So the number of distinct permutations are 11 factorial over 4 factorial times 4 factorial times 2 factorial. Now, you have to put a parenthesis around that bottom or you're going to get the wrong answer, because otherwise the calculator will say 11 factorial divided by 4 factorial times 4 factorial times 2 factorial and give you a totally wrong answer. So 11 factorial divided by parenthesis 4 factorial times 4 factorial times 2 factorial. And there's your answer, 34650. Okay, so use that factorial button. The homework isn't hard. It should not take you very long. Have a great day, and I will see you on Thursday.